Good morning to all. Welcome back to Google Classroom of Sri Gokulam Public School, Guruvayur. I am Beena, your math teacher. In last week, we studied different properties of parallelograms, midpoint theorem, as well as its converse. Okay. And also we seen that some problems based on these properties of parallelograms and midpoint theorem. Okay. So you have to study all these things well. Write and study, once again remind you, write and study all these problems given in your textbook. Okay. So in this video, we are going to discuss two examples that also given in your textbook based on midpoint theorem and its converse. Watch the video carefully and attend the test paper. See here, I given some assignment problems. In last chapter also I gave some assignment problems. So complete that assignment work and submit to me. Okay. Here also in this chapter also I will give some extra questions based on this concept and take your own time and submit all the question answers. Okay. So, dear students, that's about our chapter quadrilaterals, and we will see the extra questions based on this chapter. Okay. So anyway, thank you all. Let's see the example. L, M and N are three parallel lines intersected by a transversal P and Q such that L, M, N cut off equal intercepts AB and BC on P. Show that L, M, N cut off equal intercepts DE and EF on Q also. Okay, let's see the proof of this example. In the question, it is given that L, M, N, these three lines are parallel lines, and these parallel lines cuts by a transversal, isn't P and Q. Okay, these two lines cut these three parallel lines, and also given that AB length and BC length, these two lengths are equal. So listen, L, M, N, these three lines cut off equal intercepts AB and BC on P. This is given in the question. And we need to prove the same line L, M, N cut off equal intercepts DE and EF on Q. That means we need to prove DE is equal to EF. So it is given that AB is equal to BC. We need to prove DE is equal to EF. So here we are going to prove, listen, DE and EF are equal by converse of midpoint theorem. Okay, converse of midpoint theorem. So listen, in this triangle ACF, look at this triangle. I will draw it separately. A, B is midpoint, C, F. Okay. In this triangle ACF, B is midpoint of AC and this line BG. Look at here. Okay. BG line is a line passing through this midpoint and also parallel to CF. Is it parallel to CF? Yes, these three lines are parallel. So, ABC, listen, ACF triangle, B is midpoint, BG line is a line passing through this midpoint and BG is parallel to CF. Therefore, by converse of midpoint theorem, we can say that by converse of midpoint theorem, look at the figure, then we can say that the line BG is bisects. Okay, BG line is bisects third side. What is third side here in this triangle? AF. That is BG bisects AF. Or we can say that G is midpoint of, okay, G is midpoint of AF. So, okay. Now look at this triangle ADF or AFD. See this triangle AFD. AFD. Here we prove G is midpoint of AF, isn't it? Yes, G is midpoint of AF and the line through G, that is GE. Line through G is parallel to AD. These two lines are parallel. So listen, G is midpoint of AF and GE line is passing through this midpoint G and also parallel to AD. Again by converse of midpoint theorem, this GE line bisects the third side. What is the third side in the triangle AFD? Yes, it is DF. So GE bisects DF means, listen, this point E is the midpoint of DF. Okay, E is the midpoint of DF. Now listen, E is the midpoint of DF means these two lengths DE and EF, these two lengths are equal. Okay, so we proved. So listen, look at the triangle ACF and AFD. In both triangles we applied converse of midpoint theorem. In this triangle it is already given that B is midpoint. So BG is a line passing through this midpoint and also parallel to this side, and therefore BG side bisects the third side, or G is the midpoint of AF. Now since G is midpoint of AF, GE line is a line passing through this midpoint and also parallel to AD. Therefore, GE line bisects third side. What is third side? DF. So, D is equal to EF. Okay. Let's see the next example. In triangle ABC, D, E and F are respectively the midpoints of sides AB, BC and CA. Show that triangle ABC is divided into 4 congruent triangles. The figure ABC is a triangle. D midpoint of AB, E midpoint of BC, F midpoint of AC. These are given in the question. So if we join these midpoints, we can see that the total triangle ABC is divided into 4 triangles. What are the triangles? Triangle ADF, triangle DBE, triangle ECF and this one, triangle DEF. Okay. So, we need to prove these 4 triangles are congruent to each other. Okay, congruent to each other. For this, we are going to apply the result or theorem that we learned earlier. Listen, in a parallelogram, diagonal divides the parallelogram into 2 congruent triangles. Okay, in a parallelogram, diagonal divides it into 2 congruent triangles. We are going to apply the same result or theorem here. For this, let us consider this quadrilateral DBEF. Look at this. This is okay, DBEF, and prove this quadrilateral is a parallelogram. That we are going to do. Okay. So listen the figure DBEF. We are going to prove this is a parallelogram. Now listen. Look at this figure. What is the line DF? DF line is the line segment joining midpoints D and F, isn't it? DF is a line segment joining midpoints of 2 sides of a triangle ABC. So by midpoint theorem we can say that, listen, this line DF is parallel to its third side. What is third side? BC. DF is parallel to BC and DF is half of BC by midpoint theorem. Now listen, DF is parallel to BC is always same as DF is parallel to BE because BE is a part of BC. Now DF is equal to half of BC. Half of BC means either BE or EC, because E is midpoint of EC. Okay, so these two lengths are equal. So half of BC, consider here BE. So DF is parallel to BE, DF is equal to BE. Look at here, DF and BE. These two are opposite sides. So here we prove these opposite sides are parallel and equal. So in a quadrilateral, one pair of opposite sides are equal and parallel implies DBEF is a parallelogram. Okay, DBEF is a parallelogram. Now DE is diagonal. So this diagonal divides the parallelogram into two congruent triangles. So listen, the triangle DBE and triangle FED. Okay, DBE is congruent to triangle FED. So we can order this. Triangle DBE is congruent to, listen, triangle equivalent to DB. It is EFD. Okay. DB is equal to FE. Okay. DE is common. Then BE is equal to what? DF. Okay. Now it's okay. Triangle DBE is congruent to triangle EFD. Okay. Similarly, from this figure, consider this quadrilateral. Look at here, DECF. I will draw. Look at the figure, DE. Okay. DECF. Again, DF line is a line segment joining midpoints. So again, by midpoint theorem, DF is parallel to third side. What is third side? BC, and it is half of BC. So DF is parallel to BC and DF is half of BC. Here we take DF is parallel to BC. That is parallel to EC, because EC is a part of BC. And DF is equal to half of BC. Consider EC half part. So look at here. DF is parallel to EC and DF is equal to EC. So one pair of opposite sides are equal and parallel. Therefore, DECF is a parallelogram. Okay, DECF is a parallelogram. So if we join its diagonal, look at here, diagonal EF. This diagonal EF divides the parallelogram into two congruent triangles. What are the triangle? Triangle DEF is congruent to triangle CFE. Okay, these two triangles are congruent to each other. Similarly, consider ADEF. Okay, ADEF equilateral, and prove ADEF is a parallelogram, and therefore DF diagonal divides the parallelogram into two congruent triangles. So listen, in this parallelogram, these two triangles are congruent. DBE is congruent to DEF. In this parallelogram, CEF is congruent to what? DEF. And in this parallelogram, ADF is congruent to DEF. So these three, 1, 2, 3. These three triangles are congruent to the same triangle DEF. So we can say that all the four triangles are congruent to each other. Okay. So that's our example.